Hello, everybody. Welcome to the GSE UK Conference 2021. This is session 2BA, and Sebastian Lawrence is going to be talking to you about Red Hat OpenShift, multi-cluster and multi-architecture. Any questions you might have, can you put them into the chat, and I'll monitor that and let Sebastian know if there's any questions. Thank you. Over to you, Sebastian.
Okay, great. Thank you very much, David. So I'm Sebastian Laurency. So I'm an IBM executive architect working in the IBM Garage for Systems, located in the south of France, so in Montpellier. And I've been working with some of my colleagues from other platforms on different scenarios related to the deployment of Red Hat OpenShift on different platforms. And we come up with a demonstration here that I will go through today. That will be a live demonstration, so hopefully we'll go through it quite nicely. But as an introduction, I have a number of few slides to position, let's say, the environment and the scenarios, of course, that we're going to see together. So what we created is a simple, let's say, application, which is called Sushi. Application. So it's like, 24/7 online restaurant for the scenario. And we consider that this is a worldwide delivery for this customer here. And one of the challenge that the Sushi Web, company wanted to achieve is to decide what is the right provider for them to host their applications. And of course, they got multiple choices, right, in Amazon or Azure or Google. And finally, in fact, Sushi Web selected IBM to support its critical online application. And one of the main reasons is that Sushi Web application is running on x86 servers, and they got this deployed, and they got a containerized version of this application, right? But they also acquire recently the Power 10 servers, right? Where they also run the Sushi application on premises. So they want, in fact, to have the capability to deploy this application across multiple platforms. And of course, this company, as a fictitious, of course, company, we consider also that is having, let's say, an IBM Z and Linux One servers as well, which are on S390X architecture. And we wanted to demonstrate that the same source code, the same application can be deployed across multiple environments, and how we can achieve that with our solutions today, our containerized solution, particularly the one, of course, we get on the IBM Z platform, but also how to make this work across multiple architecture for them. So the Sushi application now, and that's one of the challenge, is to explain how we can achieve this target architecture and have this application running across multiple clouds. So if we come back, let's say, to this, one of the things about the containers that we want to have as a common, let's say, information and to share that, we are simply, creating applications which are based on containers, and containers embed, the application binaries as well as their dependencies. Okay, so it's binary, it's tools, it's libraries, everything is inside, in fact, the container. And this is running on a host kernel, and that's true for all the different servers and all the different operating systems on which you can run containers. So on the Z platform is the same, but the challenge we have is while you stay on the same architecture, you can have multiple host kernel, meaning that your container can be moved from an Ubuntu operating system to a Red Hat operating system, and this quite transparently. So the value of the containerization and the containers is to have this easy redeployment to any kind of runtime or environment where you have multiple operating systems, okay? And sometimes this is also confusing people, because you may think that if you have a container running on x86, like the Sushi Web application, you can take this container and move it to a different operating systems, which could run on S390X or on our Z box, for instance. And that's not exactly the case. In fact, the application binaries and dependencies are packaged into the container, But then there are some specific host kernel interfaces, right? Where we have some specific code for the drivers that exploit the hardware or the underlying hardware architecture. And this is one reason why they are architecture dependent. So containers are architecture dependent. So if you want, in fact, to move your container from one architecture to another architecture, you have to rebuild, in fact, a new image of that particular container, of your particular application, right? And in order to do that, usually you have a recipe file that is used. So most famous, I would say, file is called the Docker file. And this is a recipe that contains some declarations, right, on how and what are the different steps to recreate your image up from an existing, right, description or an existing image. And you have, of course, to slightly change some statements into that Docker file, potentially to be run and executed on a different architecture like a Power server or an IBM Z server. So the challenge here now is how we can build a single container image, but this image could be run on any hardware architecture in the underlying, and particularly that's true also for our IBM Z platform. So when you get into multi-architecture and different container images, of course, usually they are not multi-architecture. There is a specific statement which is a multi-architecture specification. And what usually we are doing is we can create what we call a manifest file of your application. So it means that in some way you have to create and build an image for the Power architecture. You have to create, for instance, an image for the x86 architecture, for the Z architecture, and then you have a manifest file where you have your application then file. And in the registry, all the developers that are using your particular application code, they will only see, in fact, this application manifest file, which is in fact a multi-architecture file here to be deployed either on Power or on, let's say, on Z, for instance, right, during the deployment. So if we are having this environment now in place, how to create or generate this little file is quite easy. You have some specific commands to create and generate that manifest file. You have your application, so you call it, for instance, app. So in our case, that's Sushi application. And then you have the Sushi x86 and the Sushi Power or the Sushi S290X application. And then you annotate your manifest file with the operating system, which is Linux, and you specify the architecture you want to support for your application. Once that's done, you can start to push your application into the registry where anyone can pull that image and deploy it to the right target platform. Okay. So one word here of this challenge with multi-architecture images is there is an architecture concern zone in the DevOps, let's say, cycle. And the interesting thing is the code part, right, is not really in the architecture concern zone in some way. That really depends, of course, on the type of application that you are going to run, right? But most of the time, if you select, let's say, language like a Node.js, for instance, language, right, which is quite standard today, and you ensure that this language is supported in terms of runtime on the multiple target hardware server that you want your application to run onto, that's fine for your code piece. So the code source, and that's what we're going to see in the demonstration, the code source can remain exactly the same, in fact. What will change is the build process here, where you will generate your binary image, your Dockerized, in fact, image, your container image. And from there, you will create, you know, this different container x86 image or the container PPC image into the container manifest file, which is just a pointer file, in fact, to the different architecture. And then the rest of the development is very similar, right? Microservice integration, application deployment, or upgrade is very similar then, because that's handled by the operations part. And in our case, that will be handled by the Red Hat OpenShift container platform. Okay. So what we're going to see here is we're going to have a Git repository. In this Git repository, we have a master branch, right, which is our main branch here. And from this main branch, we are going to have a Docker file with different commands, and we're going to deploy, let's say, multiple applications, and we're going to expose a specific route for our users, right, into this environment here. So here, let's move, and I propose, in fact, to move here to the demonstration part. So here, what I will do, I will switch here. Okay, so I get still my screen share, right? So it's still working. Just checking here if everything's all right. Yes, okay, that sounds good. Let's switch back to the environment here. So here I'm connected to an Argo CD interface, right? So the Argo CD component is one, let's say, of the solution that are part now of the Red Hat OpenShift, where you can use and deploy this component, let's say, as an operator inside Red Hat OpenShift. So let's connect to this environment here. Okay. So this Argo CD operator, right? I'm not going to the installation of this Argo CD component here, but that's simply an operator. So you can have it into the catalog of Red Hat OpenShift, and you can select that component and say, I want to install the Argo CD component. And then you have this little application here with this URL where you can connect and access to. And that is a tool that will allow you to orchestrate, let's say, the deployment across multiple environments. So in our case, what we are going to do here is we have a specific, let's say, Argo CD environment here. And this is available on GitLab. So anyone can access to this environment here, right? We shared this one. So if you want to practice or to access to what you will see in the demonstration here, you can access to it. We also shared a number of scripts here to connect automatically to the different clusters or to perform deployments, clean up the different applications across multiple environments. And then we have, of course, a little scenario here that you could use and that we're going to go through during that demonstration. So coming back to this environment here in Argo CD, if we are looking to this environment, what you will see is a multiple set of repositories that can be connected here and that can be defined. So it could be some Helm repository if you're using Helm. In our case, we're going to use a Git repo here, right? So you can have different set of repository and connect it to this environment here. The other things we have, which is interesting for us, are the clusters, right? So the clusters needs to be predefined into this environment here. And we define 3 different clusters. So we define, in fact, our sandbox, right, which is one environment running on the x86 environment here. We define, let's say, our the power servers, right? And then define the demonstration, which is our Z cluster running on the S390X environment. So we get those 3 platforms installed. And what we will start with inside Argo CD, you can directly create your application, right? So you can say, I want a new application here, right? And you can, and what we will do is we will first create, you know, a proxy, and we will use that proxy to communicate with 3 different clusters. 2 clusters will be in production, and 1 cluster will be, let's say, a backup kind of cluster, which will be on production as well, but it will be on x86 server. So this little proxy application that we will create right now will allow us to load balance the different traffic between the different Red Hat OpenShift clusters hosted on multiple environments. So when you create your application, it's quite simple. We need, in fact, to provide the name. We let it into the default project. And here we have a synchronization policy, which look into the Git repository for the configuration that we pushed there. So we want it to be automatic and to be in sync with the Argo CD environment. So Argo CD will check that if there is a change of within the deployment of the application in the runtime, if there is a change there, we can automatically recover from that change, right? So that's a very nice feature, and we're going to demonstrate that how this is working. So then we need, in fact, to provide information related to the GitLab repository. So we're going to use, in fact, the Argo CD demo Git repository. And here we have to specify, you know, the paths to the environment. So we have multiple, what we call the overlays, which corresponds to multiple configuration for the demonstration. So we're going to pick up the Asha proxy sushi overlay demonstration, right? That's the one we prepared as a configuration to deploy this environment here. Interestingly, inside this environment, we can also select different clusters, which are the destination cluster to host this particular application here. So of course, we can specify different IP address, but in the latest version now, we have the capability to retrieve by name. And that's what, in fact, we want to do, because we want to target, let's say, the x86 server. And we're going to deploy that proxy on the x86 environment in our environment here and there. And then here for this namespace here, we're going to select the Argo CD demo, which is the namespace in which we are going to work. Of course, we could position it in multiple or different, let's say, namespace, but this is the one that we are using in this environment. So now that we are ready with that, we can just simply create that new application. And that is now going very fast, because here, when I open the sushi proxy application, I can see, in fact, in live, the deployment of the multiple artifacts which are going on inside the Red Hat OpenShift cluster. So if you're familiar with Kubernetes, right, most of the artifacts we have in Kubernetes are represented here into the Argo CD environment. So we can find, again, the routes, which are defined. We can view the service here. We can see the deployments. We have, of course, the pods here, which are there. And we can switch and have different view of this particular service, right? A much simplified view for us is that service, and that service, right, is connected to the different pods that we have. At this time, we have one pod, which is just running into our environment, okay? So now that we have this environment here, we could simply try to connect to that proxy servers, okay, that I just created. So let's have a look here now to the URL for the proxy. We're going to load it, and here we go. So we have, in fact, the Asha proxy application, which is now in a containerized form, deployed in a Red Hat OpenShift cluster on x86. What we are seeing now in this environment here is that we have multiple, let's say, groups that we created. We created a sushi production environment. This sushi production environment is having multiple, I would say, clusters inside. So we can review the demo x86, the power, and the Z cluster. At this time, all of these requests here are red and are not everything is down, of course, because this proxy cannot reach to any application, right? We did not yet deploy the sushi web application. We just deployed the proxy, so we cannot join the application, which explains why everything is down for the moment. One thing also I would like to highlight here is the server weight that you are seeing in that demonstration. We set it to 100 for the Power platform, and we set it to 100 for the IBM Z server. And we set it to 1 for the x86 environment. This is because we want this proxy to push the request to the Power and the Z environment and to workload balance between the two architecture, right? So two different clusters of OpenShift, but we want to go to one platform and then the other. And the priorities for those two, and we don't want to get to the x86 server. In case of a problem on the Power or on the Z server, which could be a problem, for instance, on-premise, right, on the on-site environment, I want automatically my end users to be redirected to the cloud, so the IBM cloud server, right? So that's the x86 default environment we have, where we have a Red Hat OpenShift cluster running there, and we want to move, in fact, the application into the IBM cloud, where we have the Red Hat OpenShift hosted. And we will again do that in the demonstration. We'll show that scenario as well. And for the other part of the scenario, it's also a DevOps scenario. So we wanted to show how to make a modification of our Sushi application and how one change in the application side can be pushed automatically to all the different clusters hosted on multiple architecture. So in order to do that, we have a Sushi development environment, which is a local x86 server on which, in fact, the developer, of course, is working. And that's the one we're going to use in our scenario. So we have a different group for the development and another group, of course, for the production environment. Okay. So now that we've seen this environment and I explained you the different workflows that we're going to see, we have, of course, to get the Sushi web application up and running. So I can come back, in fact, to this environment here in the application, of course, and I can do it from the new application tab, which is there. And of course, I will push the application, which is a Sushi application, to the x86. I can do a new app, deploy it to Power. I can do a new app and deploy it to the Z. But we want, in fact, to get some automation in those processes. So Red Hat OpenShift cluster can be used, and particularly also the Argo CD component can be used through REST APIs. So what we did is we created a number of scripts into our environments, and we are capable to use, in fact, scripts. So that's what, in fact, we're going to use here. So this is one of our servers on which I have prepared, let's say, different environment here. So I can connect to this one here. Okay, I'm logged in. And what I will do is with a simple command here, right, I will kick off, let's say, the deployment of this entire environment here that I want, right? So I want to start the Sushi DevOps demonstration. What these scripts will do is typically going to deploy to the different clusters automatically this application from the repository we've seen. So single repository, multiple target platform, and that's automated. One way to automate this part is also to use the Red Hat Ansible Tower. So that's a different solution from Red Hat that you could use, which is the Ansible platform through playbooks. So you could entirely code these scriptings and this demonstration as well with a Red Hat OpenShift Ansible that could be used, right? For the purpose of this demonstration, we started to create those two ones. So here we go. We launch, in fact, this environment and this demonstration now. And we're starting to see in our Argo CD interface, let's say, multiple deployments which are going on. First one here is the Sushi dev environment here. So we are using the Sushi x86 server. So if I'm getting into this one here, we have here the deployment of our Sushi application. This Sushi application, right, is hosted in the GitLab repository. So I think we can get to the GitHub repo. So here is the GitHub repository. And in this GitLab repo, we get a simple website here. We get a Docker file here that has been provided. And when we come back to the Sushi web application here, we are seeing that a number of components are being built. So if I'm just simplifying, the deployment here, I'm seeing that I have a pod currently deployed into this environment. So the nice thing with the Argo CD component, as you can see already, is that we are retrieving information from the different clusters to which we are connected, right? And we can directly see, in fact, from that interface, some of the logs, right, from the pods that are deployed on each different architecture. So we can really follow what's going on into the deployment here for our Sushi web application here in our environment. Okay. So typically, that's one thing we can do from this interface here. But of course, we not only have, let's say, this deployment which is going on, we can take a look now to the other environment. So we get one here, which is on the Power Sandbox cluster. So this one here, as you can see, is ready, is running. So we have this environment. I would like to take a look if I have one which is currently in deployment. And here is our Z. So we have our Z. Okay, good. We have a build here. So let's take a look here as well. In this environment, I could take a look to the build phase here, and I can take a look to the logs. Right. And here I have this information. So here you see the different deployments, what I explained before in the presentation where I said we need the Docker file from which we are going to rebuild from the different targets, right? From the different, let's say, for the different platforms. We have this Docker file, and this Docker file here contains multiple statements. As you can see, we're using an UBI image, which is an HTTPD server from Red Hat, which is one of the first steps we're going to use. We are going to copy the website into the var w HTML inside the container environment. And we are going then to run a specific set of commands which are being, let's say, which are using environment variable depending on the hardware architecture. So you have to think that these particular recipes can be applied to multiple platforms because we included into our different steps in the Docker file some statement regarding the architecture. So we are performing queries uname -am to retrieve, in fact, different architecture on which we are running. And we are then building, in fact, that particular template and the right page and the right deployment that we are updating into our index template. The reason why we are doing that is because we want, when I will call the page of my Sushi application, to indicate on which cluster of OpenShift this particular page is served from. So, right, so if I'm on x86 or Power and so on, right? So again, this push is successfully done into the environment. So again, that means that we get now different applications which have been deployed to the multiple cluster we have into our environment. So the next step for us, of course, is to access now the application and to evaluate that our Sushi proxy is pushing the request to Power and to the Z server clusters. So let's have a look now into our Sushi Everywhere URL. So if I'm accessing to this one, here I have the Sushi Made, this one for Technical University. So we get that Power image here, and if I refresh that page, here I should be in a different architecture, and here we go. We get S390X architecture now. So we're running from the OpenShift cluster running on the Z box now. So we can alternate those calls, of course. So if I'm each time doing that request here, I will update the page and I will move from the Power architecture to the S390X architecture and so on. Okay, workload balancing, in fact, the request to the two clusters. That's one thing. Now, I told you, if you remember, when I deployed Sushi proxy, that we get a way to reconciliate automatically, in fact, this environment with my Git repository. And that's also something very interesting and agile to do as a potential developer that wants to deploy the environment. So what we're going to do now is we're going to get into the Sushi Power environment, and we're going to remove the service. Right? So I will, and I can do that from the argo cd command to add to multiple applications, and I want to delete now that service. So if I'm doing that delete of the service, I need, in fact, to confirm. So let's say, yes, I want to delete it. Okay, let's delete that service. And I want now to do the same on the IBM Z server. So you can imagine, right, that could be, we don't know, right, a problem, a failure, whatever with the service, be a different set of issues that may happen, right? But we want, in fact, to use the feature, which is a reconciliation feature from this Argo CD environment, which helps us to manage a multi-architecture deployment. So here, I'm in the application side, coming back to this one. And what I have now is my Sushi Power and my Sushi Z, which are indicated out of sync here, right? That's because we get the automatic check to the Git repo. In that Git repo, we get, in fact, the configuration for our application, which is also part of that Git repo. So when the Argo CD is checking to what has been currently deployed and running into the different OpenShift clusters, it can detect that there is a difference of what is the specification provided in the Git repo versus what is effectively running today in the environment. So what we can do is we can, in fact, synchronize this application. So if I'm selecting synchronize the apps here, I can simply say I want to synchronize those different here, those two here, and I want to sync again this one. Syncing complete, and that's it. And now I have the syncing here, which is going on into the environment. So if I'm connecting to my Sushi Z application here, and this is just syncing, what it's doing is checking the configuration into the Git repo and is reapplying it into the cluster on my Z box that is currently running. So what should happen here is that I will have, in fact, my new service that will be created and my pod will be generated automatically, in fact, for that particular application deployed into that cluster, right? And I will have the same, in fact, things that will happen into the Power environment as well. So this one here is still syncing in this environment, and the Power one, so let me remove the filter here, but the Power is already synced. And I think this one on Z as well. Okay, here it is. So here now the Z as well is resynced automatically. So I have the service again, and I have my pod again. Okay. So in fact, in my Sushi proxy, I can see again that the two servers, right, Demo Power and Demo Z clusters, are accessible again in my interface, right? I should have shown you that they were down before, but typically, you can believe me, those two were down, and now they're just up, right? Because I restarted those two. So that's one of the nice features we have for the Argo CD and the management of multi-cluster application. Now, the challenge is if I want to make a modification of the code inside my Sushi web app application, how that can be handled, and how that can be pushed to the different clusters now that I have in this environment. So we're going to do it in two steps now. So the first step we're going to use is we're going to get to the repository. And into the repository here, which is the Sushi web repo, I will dig into the website. And in that website, I have this index HTML file. Okay. As a developer, I can access to this file, of course. So you can use your preferred tool. You have many tools here. I have my Visual Studio Code or my IDZ, so IBM Developer for ZOS, and so on. So I can use many tooling, but simply here, what I can show you is I can simply edit, in fact, this environment here, right? Very quickly. Yeah. Redirecting. Oh, yes, I need to sign in again, I think. Yes. Let's sign in. Because I have to authenticate myself. So I'll use my GitHub, in fact, ID to connect to that. And I will simply edit this page. So now I'm connected with my Git ID. And what I will do is I will scroll down a little bit into this environment. And what we're going to do here is I'm going to replace that take you here, right, by the GSE UK. Okay. So I made, as a developer, I could do, of course, much more complex change here, but that just to illustrate, you know, the scenario here. So let's commit that changes, that change. So if I'm committing that change, right, as soon as I'm committing that in my Argo CD environment, the developer part here, I will have automatically a new rebuild here that is going on. You can see this build here. This is currently building a new pod and a new application will be deployed here. So this is because that change as a developer that I made is automatically pushed to my OpenShift cluster in the developer environment. I can very easily test, in fact, that change into the development environment. So of course, if I'm getting to what you can see here is what we've seen before, which is the execution of, again, a new image that has been built. And from that image, I will regenerate, a new pod, okay? So what it means that as a developer, I made my modification and I changed only the development cluster of my OpenShift. So in order to do that, it's quite easy to check that I made that change. So I can get to my sushi everywhere. And if I'm doing enter here, as you can see, I'm going to power and it's still for TechQ. If I'm doing then a reload, I'm going still for TechQ on S390X. So my workload balancing for the production environment is still there. Now, if I want to get to the development environment, I will simply add dev.sushi everywhere in front of that URL, and I will look to my x86 environment now. My cluster of OpenShift on x86 for my development environment has been updated with GSC UK, right? Which is the change that I wanted, in fact, to test in my application, my code. So quite simply, as a developer, I can continue to work in my environment, my x86 cluster of OpenShift, to validate that my cluster and my containers are having the right changes applied to this architecture. But I can also now decide to push that change to the production environment, okay? So if I want, in fact, to move now to the production environment, what I will need to do is to come back, of course, so I would go back here. So come back to this sushi everywhere, which is my production clusters running on a different platform and the Z box here. And now I will go back to the GitLab part, okay? And in the GitLab part, what I need now to do as a developer is to make a compare between the different branches that I am using, okay? So let's take a look now and do a compare in this environment here between the two different branches. So if I'm doing that comparison, okay, let's take a look. Okay, good. So I have my two different branches here, right? So I can compare my branch, which is my master branch, to, in fact, the production branch, right? Okay, so my production branch, if I want to compare my master now to the production, I should see the differences that I included into the different files. So you can see, of course, the TechQ versus the GSC UK architecture that I made as a change. So as a developer now, and not really as a developer, but in fact, as the one that get the authority, right, of course, to create the merge request, I can send, in fact, that merge request and said, okay, I validated into my environment that this new change is fine with me, and I want it now to be pushed to the production environment. And you remember the production is running on all different clusters, different architecture. So I'm creating that merge request, okay? I could assign and do a lot of things in the descriptions and the approval process, of course. But for just this demonstration, it's just to show you the process here for making the deployment. So here, okay, I have this environment here, and that's done, right? So now I can just accept and say, okay, I want to merge this. So I'm okay. That's fine. Let's merge this environment, okay? So I merged this change into the environment. So what is happening now, it's again automatically handled by the Red Hat OpenShift clusters. What it means is if I'm getting back now to my applications and all my different clusters here, this change that I pushed, in the production environment now, should be reflected, and in all the clusters I should see now a build for all the production, and here it is for the power server. So the power received the instruction now to redeploy the application in the production environment. I can take a look in the x86 servers here. And I should have also redeployments. So I think this one is performed already. So let's take a look to the ZBox, because it's quite fast sometimes here. It's okay, yeah, this one is ongoing, so we can take a look. So here we have the deployment, of course, here also, which is a new build of this application, which is handled, right? And this is perfectly automatic, right? I did not have to do anything else. Of course, if you want to make a control to the deployments and you want to perform additional tests, that's fine. You can include, in fact, those changes or different, let's say, slightly different workflow in the deployment of your target platform, if that's required. But usually it's good to have a common, in fact, workflow and pipeline across a multiple architecture. The difference to handle the architecture from an application point of view is handled in two places, like we've seen in the slide that I show you, is first, if you have to point to specific packages for x86, Power, or your ZBox, this is something that you're going to code right into the Docker file. So you're going to say, I want the HTTPD package to be installed, but I want it for my right target platform. And that's something that you made to modify. But from an application point of view, if that's written in the Node.js language, you don't have to modify your Node.js code, right, and your Node.js language. So the developer does not need to do that. If a developer is calling some packages which are embedding binaries, which are binary on x86, for instance, of course, you have to make a modification, or you have to have a dependencies which is also supported on your target architecture, right? So the level, I would say, of compatibility or interoperability, in fact, for your applications across the multiple clusters will also depend on the applications and the underlying packages or frameworks that you want to support. So you need to be aware, if you want to create your multi-architecture environment, in order to do just what I show you here, you have to be sure that your source code here and the way you coded it into your Docker file here is flexible enough, right, in some way to support those architecture, like the variables we included for the architecture and things like that. So it's same thing for the packaging part, right? The application package you want to install in your containers, right? That's something you need to take a look. The runtime and the languages, of course, needs also to be checked, right? Depending on the level, versions, things like that. But what I wanted here to highlight is much more the infrastructure or the GitOps capability today we have with the Red Hat OpenShift cluster across multiple platforms, and particularly also on our Z environment, right, which allow us, let's say, to have multiple applications deployed across multiple clusters. So now what I will need, in fact, simply to do, so let's just check in here that everything has been deployed. So we see still a deployment here. In this environment that is going on, I think the Power server has been deployed. Yes, so this one is okay. So we should wait just, I think, for this one here to end. Just checking what this one is doing, taking a long time here. Okay, making the logs here. Okay, waiting to start in container creating. Okay, it's waiting to create a container on that one. So we'll see. So anyway, if we want to access our sushi everywhere, and if I update it, at least I should be served, and I should be. So this is the tech queue here, and the Power is already updated. So we get the GSC UK, which is updated into the production environment, right? Okay. So that's also something that you could decide on one platform if you want, in fact, to update one piece of code, but potentially not on the other one. That's also something you could potentially do. But here, the idea was to, in fact, make the reflection in the two environments, right? So one container is still creating in one environment, but we should get, in fact, the two, and our workload balancing still running, right? So the application is still creating right now. Okay, so that's, in fact, the thing I wanted, in fact, to show in that demonstration here. There are additional statements and things that you need to take a look at. So let me just check here. I will relaunch, in fact, that one here. So let's come back to the presentation here. I think I had a little maybe crash with that one, so I will simply reopen it. It should be quite quick. Just this one here starts. I'll simply recover that one. So in the meantime, do you have some questions, right, for what I just show you up to now with the demonstration here that we have? Just checking if this one here is syncing or still deploying. Yeah, I think there is something. The deployment. Do you have some questions in this process here? Okay, finish. If there are no questions, so what I will do is I will come back to the presentation now. Yes, here we go. Slideshow. Let's start from this slide. Okay. Okay, let's move on. So what we have seen is the different deployment across those different platforms, right? I mentioned and we discussed already about that. So let me move on to kind of recap what we've seen. Demonstration here. Fine, manifest file, we've seen that. Deployment from the image registry. Okay. Live demonstration. Okay. So as a summary, right, of the different things we have seen during that demonstration is the first one, and the scenario we covered is the Asha proxy. We get those two primary call to the IBM Z and the Power architecture, and the x86 server on the IBM cloud servers that we were calling. And what we did is we had, you know, our Git repository, and Argo CD read from that Git repo, and it has been the capability to deploy automatically to the different cluster environments. So the Asha proxy plus the application for that demonstration has been automatically pushed. You have the code available on the GitLab repositories that you can use. The Argo CD environment is available now within, in fact, the Red Hat OpenShift cluster. It's an operator that you could install. It's a kind of a single point of control, right, for multi-cluster environments, right? We've seen that it can track any deviation and it can remediate to it automatically. And it's quite easy to integrate into a CI/CD pipeline. So if you're using a Jenkins, for instance, for all the build process, that's also something that you could use right with your Argo CD, right? And the other thing is the automation part. We provided the scripts to interact with the Argo CD. So easy command line to access, in fact, to the deployment and the operations you want. And the other and last scenario that we have seen is the way to rebuild automatically the different applications after a change. We compare the two branch, the master branch and the production branch, and we've been able, in fact, to merge and to push the merge request. As soon as a developer makes a modification, it is pushed to the x86 development environment. And then when we get to the production branch, this production branch there, we have some webhooks, in fact, which are specified in the environment that allow us to automatically rebuild the application in the different clusters, okay? So, and I think that's it. So that's what we've seen as a recap, right? We get our dev is pushing this request into the V2 environment. We're evaluating the V2. And if we're happy with it, then of course we kind of merging that and pushing it to get the V2 in the different clusters. And my last chart here will be on the Advanced Cluster Management. Maybe you heard about Red Hat OpenShift Advanced Cluster Manager, RACM. This is, in fact, the solutions that comes from, maybe you heard about it, the multi-cloud manager solution. It's a kind of evolution. It is part of the Cloud Pack for multi-cloud management. And this RACM solution allows you to deploy in one namespace, one project, and to push that namespace in multiple clusters as well. So you get a visual view, slightly different from the one provided with Argo CD environment, but this is a kind of complementary, right, in terms of service capability that you can have with this environment. You get a placement policy, for instance, that you will not have into the Argo CD environment. So you can decide what are the criteria and the reason why you want this particular application to fit with the Power Platform or a Z platform or x86 server, right, or potentially a cloud environment. So it has, in fact, other functions and complementary functions, I would say, compared to just the Argo CD environment. But if you're looking for managing multiple Kubernetes clusters of different architecture, I hope that the demonstration you've seen here, including, in fact, your Z platform, part of this entire process, is something that you can evaluate and you can look after, right? So I think I'm done with that. We tested it, of course, in our center with multiple clusters. We get one cluster on our Z15 machine hosted in our center in Montpellier, and we get 3 different clusters in IBM Cloud, so 1 Kubernetes cluster and 2 Red Hat OpenShift cluster, and 1 cluster also in Azure, and we can show, in fact, some kind of a failover from one environment to another. We also get this type of demonstration of failover from Amazon to our Red Hat OpenShift on IBM Z servers. So this is another set of demonstration, of course, but we get multiple kind of things if you're interested in those mechanisms across multiple platforms. So as a summary, I just show you one part of the capabilities we have today with our IBM Z and the containers on IBM Z servers. You have to know that this is available, of course, on Linux One server with Red Hat OpenShift. For our Linux on Z as well, get the Red Hat OpenShift container cluster running. And for those of you which are interested on the ZOS part, we also get the way to come to run containers on the ZOS. So this is called ZOS Container Extensions. So it's the capability to run the exact same Docker, which is a sushi application you've seen on the S390X architecture, but we can run that into a containerized environment running directly inside ZOS, right? So that's also some capabilities. And we get a different set of demonstrations available with a banking showcase environment we have in our center, where we could demonstrate ZOS Connect, we could demonstrate open development, Zoe, Cloud Packs for data, and things like that, okay? So wide range of capabilities to the other Z. Do not hesitate if you have more information, more questions, to reach out to me. I thank you very much for your attendance to this session. I hope you enjoyed the demonstration, and it helps to clarify some of the capabilities and the way to deploy multi-clustered applications to multiple platforms, and some of the capability on the tooling we have available. So please, this session is 2BA, and provide your feedback. I will appreciate that. And I'm ready and open for any questions now.
Okay.
I don't know, David.
Okay, thank you, Sebastian, and thank you everyone for attending.
So,
there are no more questions, no questions in the chat. So I think we can call it a day. Thank you very much.
Yes. Okay. Perfect. Thank you very much.
Bye.
Yes, you're welcome. Bye bye. Thank you very much.